Let's talk about triangles for a minute and the idea of congruent triangles. Triangles are figures, and we know that congruent figures are identical in size and shape. We could say that they are exact copies of each other. These three triangles appear to be different since they are oriented in different ways and they are different colors. I know these triangles are congruent though because I traced each one with the same template. See? I just transformed each one differently. It doesn't matter that each triangle is a different color, because only size and shape matter for congruency. What if I want to know if two triangles are congruent and I didn't create them? How much information do I need to have about each triangle to be able to conclude whether they are exact duplicates of each other? If both triangles were cut out of paper, I could just put one triangle on top of the other to see if they match, but they're not, so I'm going to have to find another way. Well, if I have a ruler, I can measure the sides of each triangle. I can say that two triangles are congruent if they have the same 3 side lengths. I'll measure the side lengths to find out. Let's do the shortest one first. 6 centimeters, 6 centimeters. Do the medium-sized one next. 7 centimeters, 7 centimeters. Let's just check the last one. 8 centimeters, 8 centimeters. It appears that these two triangles are congruent since their corresponding side lengths are equal. What else can I find out about the triangles that is the same? What if I measure their corresponding angles with a protractor? Their angles are the same too. So can I say that if two triangles have all corresponding angles equal, then the triangles are congruent? Not so fast. Let's take a look. This triangle has the same angles as these two triangles, but is much bigger. Check out the same angles. So 3 identical angles isn't enough to conclude that two triangles are congruent. I wonder if I can get away with knowing some combinations of different pieces of information about two triangles. Let's test out some things that compare. How many different triangles can I make when I have one angle and one side fixed? Let's use a ruler and see how many I could maybe draw. Well, with one angle and one side staying the same, there's a triangle. Oh, there's another. And even another. So I have to say that one angle and one side length the same can't be a condition for congruence. What about when I have the lengths of two sides and the angle between them fixed? How many different triangles can I make? Let's test it out. If I can't change the length of these sides, it's impossible to draw any more than one triangle. There's only one way I can do that. It looks like I can only make one triangle that has the lengths of two sides and the angle between them fixed, because the only way to get a different triangle would be to change the length of these sides. I'm going to conclude that that's a rule then. So my rule then, my new rule, is that triangles are congruent when two sides and the angle between them are the same. Since that works, I want to test something else. What if I start with two angles and the side between them fixed? How many different triangles can I make? Well, it looks like I can make just one triangle. That must be a rule too. Triangles are congruent when two angles and the side between them are the same. So now we have some rules. Can you think of some situations where you could put them to good use?